Hello YouTubers! Today's video is going to be about how to drill holes. I know to a lot of people that seems like a very simple thing, how to drill a hole in a piece of metal, but if you can think back about the time when you first got into metalworking and how tough it was to do a good job drilling a hole, not break a bit or not get the drill bit stuck, or how to sharpen a drill bit, those sorts of things, you realize there's something to drilling holes in steel, just in all different sizes and that sort of thing. The first and most important thing when drilling a hole, wear safety glasses. And depending on how large the chips are off of the coming out of the hole that you're drilling, if they're very large, very tough chips, don't wear gloves. Gloves get snagged on those things and it'll pull your hand right in. And if you're trying to drill a 3/4 hole with a good sized drill press, it can break your fingers, it can rip them right off, it can just pull you right in the machine. It's just as dangerous as a lathe. Essentially a drill bit is nothing but a lathe on its side, stood up. So be very careful. You know, I don't want to go off on too much of a tangent, but I did work in a shop one time where we had this 20-year-old guy. He's a big boy, but he was young and fairly inexperienced in the metal shop. And he was drilling a series of half-inch holes in a bunch of steel for something. And he was getting real good chips coming off, and they were starting to, you know how they come up like this, two big circular chips. What was going through his mind, I don't know, but he grabbed that chip to pull it off the drill bit, and it looped around his finger and degloved his finger. There was a lot of blood. I remember that like it was yesterday. He came running to me for some help, and I just grabbed a dirty rag. It was the first thing I could see to stop the blood. I just wrapped a dirty, greasy rag around it and told him to squeeze and go to the hospital, get it fixed. When they first came out, these drill bits with the titanium coating, titanium nitride, it's just a layer, a couple molecules thick. It's very thin. It scratches right off as soon as you start drilling anything. As soon as you sharpen a bit, it's gone. But when they first came out, they were like 30% more than a regular drill bit because they had this crappy gold coating on. That don't mean shit, that gold coating. I've tested different drill bits, brand new ones against older carbon ones. There was absolutely no difference in the way they drilled. So if you're paying extra for these gold colored drill bits just because they have this titanium coating, because titanium's a cool word, just don't waste your money. The best drill bits you can buy are, in my opinion, high-speed steel drill bits. The regular black drill bits. This is the tip of a regular drill bit. This is the same one that had the titanium coating on it. It may have been a split point when I first bought it, but it's been ground and reground, so now it's basically just a regular grind on it, right? A split point looks like this one, and you'll notice it has two grinds. It's got this grind here, and then it's got this long grind that goes down the back. And basically what that does is it eliminates some surface area on the front edge here. It will cut better. There's only one downside with that, and that is that it is a bitch to grind. So just try to buy the regular drill bits with the regular grind on them. I'm trying to get this in focus for you here, but so that's a regular grind. If a drill bit is ground and this center piece right across here, this little line is very wide, then you know you have what was originally a split point drill bit. This is the one part of this drill bit that does not do anything except hinder the drilling process. Because if you think about it, that little bit has nothing sharp to it, and it's the first thing hitting the steel, right? So when that point right there is sitting on steel, this is why quite often when you try to drill something, when you first start the drilling process, this hits the steel and it doesn't seem to drill at first. So for a minute it doesn't drill until it kind of burns its way down to the cutting edge here. When you're sharpening a drill bit, it's actually pretty easy. You should just take a big old drill bit and practice and practice, practice. You want roughly this sort of an angle. It's, I don't know what it is, like 30 degrees from a straight line here. This is probably 30 degrees. And never grind this flute here. So you got this little raised edge, and what that does, it sort of reams the hole as you're going along to the proper dimension. And as a drill bit gets old and worn, and this gets worn down and worn off, and the worst thing you ever want to do is try and sharpen that. Don't try and remove that, because without this, and when this gets worn, this drill bit's more or less trash. You'll fight with it and fight with it. It'll always get jammed. Best thing you can do is throw it out. You know, as long as it's not an especially expensive drill. Or large diameter drills, the price goes up exponentially. Like I say, get these black drill bits. They're usually the cheapest drill bit, and they're the easiest to sharpen. This one's very dull. Anyway. Okay, this is one of my drill presses. I have two. I have a large drill press for bigger things, and a nice little light one here just for doing anything up to maybe 1/2 inch. It's got a 1/4 horse motor. Seems to be a fairly well built made in Taiwan drill press. The one thing I have modified is I've built this little steel bar out of 1/2 by 1. So, the one reason I have that bar there is I get very complicated shapes like scrolls made out of flat bar, and this allows me to put them in here. I can go right around it and I can drill into a scroll, but it is very handy this way. I realized a while ago there really was no need for a big table. You just need something that will work as a backer, and works quite well actually. I think if I was to modify anything here, I'd probably gear up some kind of a gusset here on one side just to stiffen it up a little bit, because it does flex a little when I'm really drilling something big. But anyway, you got your different speeds here. It's pretty simple. What you want to do is you want to gear up these belts with a certain amount of tension, so that if they jam, the belt will slip, but not so little tension that they're always slipping as you're drilling a hole. So it's kind of a little bit of a balance there. When you're changing speeds, it's pretty simple. If you get the tension on this belt just right, you never have to mess with the motor. All you have to do is just lift up the belt on one side and roll it forward until it goes up over that. You want to be careful not to pinch your fingers. You know, it won't hurt you too much, but it doesn't feel good. You'll get good at it after you've bit yourself a few times. And pop it on the other side. And just do the same thing in reverse to change the speed. When it comes to speeds, it's more or less done by eye. A lot of times in a new drill press, they'll have a little chart here that'll tell you how big it is and how fast you should set the pulleys. It'll even tell you which part of the pulleys to put them on. A lot of times on a bigger modern drill press, you won't have 2 pulleys, you'll have 3. So you can actually change your speeds, you know, almost infinitely there. Personally, I don't like that setup because it just takes longer to change the speed. Just going to turn it on and give you an idea just by looking at the speed of this drill. See, that's very fast. I would only use that for like a 1/8 drill bit or under. This top one, which is very fast, would be a very small drill bit indeed. It would be, you know, like a 3/32 or smaller, very small, little pinholes. So I almost always leave this drill on this bottom pulley. I'm not going to change it, but, well, maybe I will, but I got to put the camera down. Okay, so this speed here is good up to about 7/16 or so. And if I have a pilot hole, I can usually get away with the 1/2 inch drill. And that's the slowest setting for this drill, which is still quite fast for a small drill. Usually you can go a little slower than that, but that's, you know, that's quite fast. You have to be in control of the pressure of the drill. Okay, anytime you're drilling something short and you can't get enough leverage with your hands, use a clamp of some kind. I like to use vice grips for all these small bars that I do. If it's something very short and you have a table on your drill press, use the drill press vise. So get yourself one of those. They're not always very cheap, but they are very handy and they're very safe. Okay, see how fast we can put a pilot hole in? Try not to drop your drill bits, you'll break them. Okay, now we're going to go back to that same pilot hole and see how quickly it goes through. Right after I drill through this pilot hole, I'm going to attempt to use this same drill without a pilot hole right next to it. I'm going to show you the difference in how fast it'll drill. That's with a pilot hole. This is without. And I'm using more pressure. The end result is exactly the same, with or without a pilot hole. However, with a pilot hole, you don't overheat the drill bit. It's cutting all the time, there's no friction being created. Without the pilot hole, that friction from that little step at the very tip of your drill is creating lots of friction and heat. It's overheating the drill bit. Once the drill bit turns colors, it's lost its temper, you have to sharpen it and re-temper it. And so that's especially important on anything upwards of 1/2 inch and bigger. You have to have a pilot hole. It's not really worthwhile on anything smaller than that to take the time to switch drills, but it's okay if you have a lot of holes to drill, because then you can put the small drill bit in there. You'll have all your center punch marks where you're going to put your holes, and then it's fast. You can just drill all those little holes first, get them out of the way, put your next drill bit in, and then drill all your big holes. It'll save you a ton of time. You would be amazed by how much time it'll actually save you. So let's move on to sharpening a drill bit. Okay, sharpening a drill bit is tricky. It only comes with practice. I can show you the basics of how to do it. There's several different methods. The main thing is you're trying to get this angle correct. The simplest way to do it is basically get online and have a picture of a drill, and it'll explain what this angle ought to be. The number really doesn't mean much. You just kind of start to see that angle whenever you're sharpening a drill bit. It's never like a 45-degree angle. It's always slightly less than a 45, depending on the material. Some materials drill better with steeper angles. I find aluminum with a steeper angle works pretty good. So some people drill down or grind downward. Let's move on to the grinder and I'll show you. Here's the grinder I like to use. It's got a sanding disc on it, and it's very safe compared to a bench grinder. Stone bench grinder, a lot of people like them, but they're really hard to keep flat. You have to dress them all the time. You have to know how to dress them safely. You're always readjusting the tool post, that sort of thing. This thing here, it doesn't have a tool post, doesn't need one. Well, they come with one because it was made for wood, but I take all that off there. It makes it even safer, so there's nowhere to jam anything. There's nothing that can fly off of this thing. The discs, they last pretty good. I can probably get a month out of a disc, and they're only like $4, so if you get the zirconium ones, they're a lot better. They'd be blue color, not these red oxide ones. You always want, when you're sharpening a drill bit or any tool, hard tool, you always want to have a little cup of water to cool the drill bit as you're sanding it or grinding it. You're actually grinding it, not sanding it. What you do, see, I work on this part of these circular discs. You only have one useful area to use, and that's basically right here, because this is spinning around like this, right? So they grind this side going upward, so they'll grind like that, and then they'll spin the drill bit and grind it up. Me, it's just my personal preference, is what my shop teacher taught me, was to grind down. So what you do, it's kind of hard to see. I'm going to try and switch to macro here. So I'm looking straight down on it now. What you do is basically you get this so that you've got the two sharp chisel edges horizontal. To start, you just bring the drill bit in, then you line that up, the original angle, with the face of your grinder. Then if you look at it sideways, when you come into it, it's straight in, but then you got to angle it up a little bit. If you don't angle it up, then that sharp chisel edge won't actually bite into the steel. So after you've sharpened it, and it's not cutting anything at all, it's just sort of riding on there and it's not doing anything, then you know your angle was a little too low, or a little too straight across. So I'm just going to do a little quick grind. Get your safety glasses on. So I get that flat. That cutting edge is flat with the face. Then I lift up on it a little bit. Then I go straight in and roll it downward. I do a couple like that. And I flip it, same angle. Okay, so this is what the finished product should look like. Just like a factory grind. You got the angle about right. And you know, I've ground thousands of drill bits over the years. I don't always get it right. Sometimes I have to go back and do a second try to get the edge just right. It's just like anything. I mean, practice makes perfect. Practice on a bigger drill bit first, because you'll be able to see what's happening easier and you won't overheat the drill bit. You'll notice I didn't dunk that in water, because this setup with the sander is a lot better for grinding drill bits. It doesn't seem to build up much heat. It just removes the metal very well, and nice and clean, and it makes just a great edge. I overheat one on purpose just to show you what to look for. If you're getting these colors like this, that's a big problem, because it's going to soften that metal, and more or less you got to grind that out of there. You can kind of do it with some heat, but it's not easy to do. So you just want to avoid it. Don't grind real hard on the damn thing. Just take little soft grinds each time until it looks just right. And then, but if you are getting a tiny bit of color, you got to dunk it very quickly while that's still hot from the grinding process. Dunk it in the water, and
And even if you do have color, it'll be fairly hard, but just try to avoid that. Sometimes that happens from using a dull disc, or you know, that doesn't happen with a stone. They just don't dull. But I like the sander because it creates a very flat profile. The cutting edge is a very straight line. Sometimes with a worn out grinding, you're going to copy this cutting edge. It's going to mimic the profile of the cutting stone. So with a big flat disc like this, that just doesn't happen. So they are better for sharpening drill bits, in my opinion. Another thing you want to deal with, I just noticed there's a couple burrs here. See these from not having your chuck tight enough? You'll spin the drill bit. You should have the belt slip before you should have the drill bit slip. You want to grind them off. See them there? You want to grind those off, because if you put this drill bit back into a chuck and the jaw of the chuck is actually up against that, then it's throwing this off center. It'll move the drill bit one way or the other. So, some of you may ask me about coolant. You notice I didn't use any coolant, I didn't use any oil. If you're not overheating the tool, why would you need a coolant? You know, you got to understand maybe why is the tool getting hot. Instead of dealing with the heat, deal with the cause. Maybe you're pulling down too hard. Maybe your drill bit's dull. Quite often that's the case, a dull drill bit. Maybe the material you're drilling is not what you think it is. Maybe it's something a little harder, and you need to deal with that from that end. But as for drilling other materials, maybe I'll touch on that someday. Most people tend to just drill steel or wood or something, but sometimes on a big drill bit, you got to put the coolant to it, you know, because the chips are, you judge it from the chips. If your chips are consistently blue or getting very, very hot, then you got to use some coolant. Best drill bits to use that are out there actually run the coolant through the drill bit. Now there's two little holes that keeps the drill bit cooled internally and pumps the coolant right into the bottom of the hole, which is genius, really. But you only see that in a machine shop application. If you're ever drilling stainless steel, just remember to drill very, very slowly. And it wouldn't hurt to use a little bit of coolant, because the properties of stainless steel, the reason the drill bit gets so hot and wrecks the edge on the tool is because stainless has very low thermal conductivity. The heat builds up in the bottom of that and it doesn't dissipate out. It just gets hotter and hotter and hotter at the bottom of that hole, and then it takes the temper out of the tool. So once the tool is softened up, it ain't going to cut. It's just going to turn red and melt. And once you put that kind of heat into the tip of a drill bit, you're going to have to grind that tip right off and try and find some hard metal in there somewhere and re-sharpen the drill bit. The number one secret to drilling stainless steel is drill it very slowly. For example, if it was a 1/2 inch hole you were drilling, that drill bit would turn about this fast, right? Not like that. It would be turning very slow, and you get a big chip coming out. And because of that, turning very slow, you got a high level of torque. So you have to be very careful not to push down too hard, because you'll snap the drill bit off. Other than that, have fun with drilling metal. I hope you learned something from it. Just let me know. You know, just remember, always anything bigger than 1/2 inch, have a pilot hole. How big a pilot hole? Well, you know that tip in the drill bit, the flat spot that I was pointing to you, the pilot hole should be slightly bigger than that, and because that's what you need the pilot hole for. The only time you need a bigger pilot hole is maybe your drill press isn't big enough and you have to drill up in steps. So if you were trying to drill a 3/4 hole with a little bitty drill press, or a 1 inch hole with a little drill press, you may have to drill a 1/8 hole, go to a 3/8 hole, go to a 1/2 inch hole, go to a 5/8 hole, and work your way up until you finally get what you want, just because you don't have horsepower to get the job done. Have fun with that. See ya.